Hai semua. Okay, tonight we continue chapter 6, radioactivity. Topic nuclear physics, nuclear physics. So under this topic, we will discuss about 6.1 radioactive decay, 6.2 nuclear energy. So to understand this topic, some of the related topic you have study in science, lower form. So I hope you still remember. Okay, harapnya masih ingat lagi lah ya. Okay, now we go to the first part. So for this topic also, I use the notes from Cikgu Sophie Blogspot. Boleh ambil dari sana kalau tak ada. Okay, let's look at the learning standard for the first part, radioactive decay. Okay. Okay, first part, explain with example, decay equation, alpha decay, beta decay, gamma decay. Apa tu alpha? What is beta? What is gamma? So this one you have already studied in lower form. Alpha is nucleus of helium, 42He. Beta is electron, 0, -1e. Gamma is electromagnetic wave. So dia tak ada nuclide notation. Then we discuss about concept, half-life. Determine half-life of radioactive substance or sources from decay curve. And then solve problems involving half-life. So ada calculation problem. Okay, ada calculation for this part. Okay, kita terus kepada bahagian 6.1. 6.2 ni berkaitan nuclear energy pun ada calculation juga. So normally in paper 1, this question will come out lah. Ada juga bahagian essay, itu bahagian yang application. Nanti kita lihat contoh. Okay, recap. Recall previous knowledge. First, look at the nuclide notation. When we talk about atom, basic knowledge of atom, it consists of nucleus and there are electron orbiting around it. Ada electron. Ini ialah atom, concept of atom. Okay, electron is negatively charged. And then at the center of the atom, there is nucleus. Nucleus consists of neutron and proton. Neutron is neutral, tak ada charge. Dia neutral. Proton ialah positif. Okay, electron negative. Okay, ini basic lah. Okay, for atom, we can represent an element by using nuclide notation. Okay, element X. Okay, so the symbol A here represent nucleon number. Means the component at the nucleus. Okay, at the nucleus there is neutron and proton. So nucleon number actually equals to number of proton plus number of neutron. Okay, we have nucleon number A equals to P plus N, proton plus neutron. And then Z here is proton number, P. Okay, Z equals to P. Okay, So this is nuclide notation. For example, hydrogen, hydrogen 1, 1. Okay, element hydrogen, nuclear number 1, proton number 1. Okay, itu contoh hydrogen. Okay, deuterium 2, 1. Okay, nuclear number 2, proton number 1. Okay, itu contoh ialah nuclide notation for element. Ada banyak lagi lah. Carbon 12 macam mana. Okay, contohnya kalau carbon 12, 12, 6. So, dia punya nuclear number ialah 12, proton number 6. Okay, if we want to calculate for neutron number, N means A minus P. 12 minus 6, 6. Means there is a proton 6, neutron 6, nuclear number 12. Okay, macam tu. Ini you all dah belajar, so just recall balik. Kalau ada apa-apa soalan, you all boleh komen. Kalau you dengan saya, you komen saja dekat chat, saya akan lihat nanti. Okay, let's look at the first part, radioactive decay. Just now, I already mentioned alpha ialah nucleus of helium. Nuclide notation is 42He. Helium, helium gas. Okay, beta ialah electron, so 0, -1e. Okay, gamma dia tak ada nuclide notation sebab dia adalah electromagnetic wave. Dia tak ada mass, tak ada nuclide notation. Okay. So what is the meaning of radioactive decay? Okay. Very simple example macam tooth decay, tahu tooth decay gigi gigi. Kalau you tengok orang muda dengan orang tua, you boleh tengok gigi orang tua semakin kecil dan panjang. Maksudnya sebahagian daripada gigi tu dah hilang, betul tak? Okay, but sebahagian gigi yang hilang tu kita panggil tooth decay. Okay, the same thing happen if you discuss about radioactive decay, means there is a loss of the mass of the nucleus. Okay, then the nucleus, that lost mass, it will emit radiation and energy, nuclear energy. Okay, let's define the process. Process which unstable nucleus. Kalau kita sebut radioactive, maksudnya dia adalah unstable nucleus. Become more stable by emitting radioactive radiation. Okay, what is radioactive radiation? This one is radioactive radiation. Okay, the process is random and spontaneous. Okay, not influenced by temperature, pressure, and other physical factors. Random and spontaneous mean we cannot detect when it will happen. What time the nucleus will become more stable by emitting radioactive radiation. Bila berlaku, kita tak tahu. We cannot predict the time. Itu maksudnya spontaneous and random. Okay, it can happen at any time. Okay, itu maksudnya radioactive decay. Process unstable nucleus become more stable by emitting radioactive radiation. Ini contoh ni unstable nucleus, dia tak stable. So it need to release out either alpha, beta or gamma to become more stable nucleus. Itu maksudnya Okay, let's look at one by one. Alpha decay, beta decay and gamma decay. If the unstable nucleus emit alpha to become more stable, we call it alpha decay. Example, general notation for element X, A, Z. Let's say emit 1 alpha. Ini 1 alpha. 1 alpha. Alpha is nucleus of helium. When emit 1 alpha, it will produce 1 new element. Let's say element Y. What happens to the nuclear number and proton number for Y? initially is A. If released helium means loss 4 for the nuclear number. So the remaining is A minus 4. Okay. Proton number, okay, also release 2. Remaining Z minus 2. So we have the new element which nuclear number less 4, proton number less 2. So this process we call it alpha decay. Okay, alpha decay. Example we have for this process, we have uranium 238, uranium 238, 92. Ini nuclide notation untuk uranium. Release out 1 alpha, 42He. Okay, what happened? The new element produced become 238 minus 4. It become 234. And then the proton number 92 minus 2, 90. So we can check the periodic table. Which element with nuclear number 234, proton number 90. So this one actually is thorium. So you can see new element produced. So this one is example of alpha decay. Actually for this process, no need to memorize this one. No need to memorize all the equation like this. You just must know the general one. Okay, you just, if you can write the general one, enough already. Just write like this to represent alpha decay. Okay. So untuk helium, you kena tahulah, okay, dia ada 2 proton and 2 neutron. Nuclear number 4, proton number 2. Okay. So ini kita panggil alpha decay. Okay, let's look at beta decay. Beta decay. Beta electron. Okay, beta is electron. Unstable nucleus. Okay, become more stable by emitting 1 beta. Okay, a neutron in an unstable nucleus decomposes into 1 proton and 1 electron. Electron is emitted with high kinetic energy. Okay, so this is the unstable nucleus, okay, become more stable by emitting 1 beta. Okay, 0, -1 E. Okay, so you can see what happened to the nuclear number A. Okay, tak ada release apa-apa, kosong. Means still the same A here, still the same. Look at the proton number. Proton number -1 release out, meaning the remaining is Z plus 1. You can check by just total up on the right side, should equal to the left side. A plus 0 A, Z plus 1 plus -1 Z. Okay, that's why here is Z plus 1. Okay, example for beta decay, neutron, neutron 10N, neutron become proton emitting 1 beta. Okay, so you can see from here, neutron decomposes into proton and 1 electron. So same process as the beta decay lah, neutron, okay, become proton, emit 1 beta. Okay, 1 beta. Okay, so you can see the nuclear number still the same for this one. The proton number increased by 1. Okay, increased by 1. So ini example, we call it beta decay. Okay. Okay, gamma decay. Gamma decay, gamma, there's no nuclide notation. Okay, if the nucleus emit 1 gamma, there's no change in nuclear number and proton number. What exactly happened is, the element initially is high energy, excited state. Excited maksudnya high energy. Kalau dia high energy, dia sangat-sangat tak stable. Dia tak stable. It need to release out the energy. So the energy release out in form of gamma ray. When release out the excess energy, it become more stable now, low energy. Okay, low energy. So it become more stable. Ini unstable, ini more stable. Release out gamma ray. For gamma decay, there's no change in proton number and nuclear number. Tak ada perubahan. Okay, example, we have example untuk gamma decay. Kita boleh tunjuk juga satu proses. Okay, something like cobalt 60. Okay, high energy. Okay, become cobalt 60, which is low energy. Okay, emitting 1 gamma. Okay, or mungkin boleh lihat lagi. Okay, uranium 23492. Okay, 92. Become thorium 230 90. Emits 1 alpha for 2He. At the same time also gamma. Okay, so this one also one example which shows nucleus emit gamma. For this one, it emit 1 alpha and gamma. So means for the decay process, sometimes the nucleus will emit more than one type of radiation. Sometimes emit alpha and beta at the same time. Okay, sometimes beta and gamma. Okay, depends on the situation. So that one we call it radioactive decay. Radioactive decay, there are 3 types. Alpha decay, beta decay, gamma decay. No need to memorize the element like cobalt 60, uranium 234, no need. Just know the general one. Ini saja, general. Okay, general. Okay. Okay, radioactive decay with more than one radiation. Ini contoh. Ini yang tadi saya tunjukkan. Ini case mana lebih daripada 2 jenis radiation. Okay, ada alpha and gamma at the same time. Okay, alpha and gamma at the same time. Okay. Okay, let's look at exercise here. Exercise. Fill in the empty spaces with suitable answers. Okay, look at the first one. Thorium 230 become radium, emit 1 alpha. Okay, so the new nuclear number here is 230 minus 4. So you have 226. And then the proton number 90 minus 2, 88. Okay, so kita ada okay, radium 22688. Okay, untuk number 2, ini ferrum. So produce new element cobalt 59 and then 1 beta. Okay, 1 beta release out. So proton number 27 minus 1. Maksudnya sini 26. 59 plus 0, 59. Okay. Okay, number 3. Ini radon. 1 beta juga release. No change in nuclear number. Proton number increased by 1. Maksudnya sini 234. Increased by 1, 91. Okay. So number 4, barium. Barium, you can see no change in nuclear number. No change in proton number. Kalau dua-dua tak ada berubah, maksudnya ialah gamma. Okay. Then number 5, protactinium and uranium. Okay, no change in nuclear number, but proton number increased by 1. Maksudnya ialah beta. Okay, 0, -1, E. That's why you must understand tadi saya tunjuk. Polonium Okay, on the right side, you just add 206 plus 4 ialah 210, 82 plus 2, 84. Polonium. Ini emit 1 alpha. Okay, yang ni number 7, radium, radon. Okay, radium, radon, nampak dia punya nuclear number sudah reduce 4, proton number reduce 2. Maksudnya sini ialah 1 alpha, 42He. Okay. Okay, number 8, emit ialah gamma. Gamma means no change in nuclear number, no change in proton number. So the same, still the same, 59, 27. Masih sama. Okay. So very simple. Ini can come out in paper 1 juga. Paper 1. Okay, mungkin test you all. Okay, now look at decay series. Okay, when we mention about radioactive nucleus, means unstable. Unstable nucleus. For unstable nucleus, sometimes the decay process not just only happen once. Dia bukan sekali saja. Okay, maybe they become stable, suddenly it become unstable again, then again ada decay process. Jadi decay process tu dia akan berterusan sehingga dia stop, sehingga dia betul-betul stable. It will continue. So kalau dia continue, we call it decay series. For example, initially ialah elemen P. Berapa kali dia decay sini? Boleh nampak? 1, 2, 3, 4, 5 sampai 6 kali decay. Okay, sampai 6 kali decay. Akhirnya jadi B kat sini. So this graph showing decay series. This one you can see the y-axis ialah nuclear number E, and then this one is proton number P. Ingat balik nuclide notation, element X, nuclear number A, proton number Z. Okay, how to rate? For P ni ialah the nuclear number 142, proton number 33. Maksudnya untuk elemen P ialah 14233. Okay, 14233 become Q. What is Q? Q is 14234. 14234. Okay, you look at the proton number and nuclear number. No change in nuclear number. Okay, the proton number increase by 1. Kalau increase by 1, maksudnya ialah 1 beta release out. 1 beta release. Jadi untuk sini kita ada beta decay. P kepada Q ialah beta decay. And then Q14234 become R. What is R here? You baca 13832. 13832. Okay, dari sini you can see the nuclear number sudah reduce 4, proton number reduce 2. Maksudnya emit 1 alpha sini. Okay, so we call it alpha decay. Okay, alpha decay. Okay, let's continue. Tengok apa yang berlaku seterusnya. Okay, daripada ni jadi R, R become S. Okay, R apa? 13832. S ialah 13430. Okay, let's say kalau kita still continue, jadi S. S ialah 13430. Ini S. Okay. So you can see again here reduced by 4. Okay, and then the nuclear number reduce 4. Dia punya proton number pun reduce 2. Okay, maksudnya sini ada 1 alpha release out. So sini ialah alpha decay. Okay, S kepada T, no change in nuclear number. Okay, no change in nuclear number. Proton number increase by 1. Maksudnya ialah beta. Okay. T kepada U, also no change in nuclear number. Proton number increase by 1. Maksudnya sini satu lagi beta release out. And then U to V, from here, nuclear number 134 become 130. Maksudnya 4 nuclear number loss. and then dia punya nuclear number reduced by 2. Maksudnya 42He. So ini adalah alpha. So means from P to become V ya. Untuk P jadi V, berapa alpha, berapa beta kita boleh calculate. Ada berapa beta? Alpha. 1, 2, 3. Maksudnya release out 3 alpha. How many beta? 1, 2, 3. 3 beta. Okay, so ini kita panggil decay series. Decay series. Okay. Ada soalan tak? Siapa yang ada dengan saya sekarang? Any question? Kalau ada soalan boleh tulis dekat chat lah. Okay, now let's look at the exercise below. Okay, based on the decay series above, calculate how many alpha and beta decays between nucleus P and B. Okay, I already just answered this one. Okay, we have P from to Q tadi, beta. Sini alpha, alpha. S kepada T tadi, beta, beta, alpha. Beta, beta, alpha. Okay, to proses tadi ya. So kita ada 3 alpha and 3 beta release out. Okay, let's look at characteristic of alpha, beta and gamma. For alpha, we have discussed just now, alpha is 42He, nucleus of helium. Maksudnya dia adalah positively charged. Penetrating power low can be stopped by a piece of paper. Ionizing power higher. What is the meaning of ionizing power? When alpha travel in air, it will produce positive ion and negative ion. More positive ion and negative ion when collide with air molecule. So ini maksudnya ionizing power high. More ions produced. For beta is electron, 0, negative 1, E. Charge is negative. Okay, can pass through paper but stopped by aluminium. Ionizing power medium. Okay, so power is less than alpha because the mass of electron is smaller. Okay, it produces ion but small amount, so we can say ionizing power is medium. For gamma is neutral, no charge. Okay, very high penetrating power, just can be stopped by few cm of lead or concrete. Okay, ionizing power low. You can see it don't have mass. Mass also is considered 0, so we can say it cannot ionize air molecules to become ions. Okay, so we can say ionizing power is low. So the high, medium and low ni as comparison between alpha, beta, gamma. Okay, so if you compare penetrating power is gamma is the highest one, followed by beta and then alpha. Ionizing power, alpha is the highest one, followed by beta and then gamma. Okay, so any characteristic of radiation, alpha, beta, gamma. Okay, now we want to discuss also the effect of electric field and electric field towards electric field and magnetic field also can towards alpha, beta and gamma. As we know, alpha is positively charged, beta is negative, gamma neutral, no charge. Let's say we have two plates. Below is connect to positive terminal, so this one is positively charged. Above connect to negative terminal, negatively charged. Let's say these sources of radiation, it emits alpha, beta and gamma. If emits alpha, alpha is positive and it will attract it to positive. So this is alpha. Okay, as for beta, beta is negative, it will be attracted towards positive. And in more curve, diffraction is more curve because beta is lighter compared to alpha. And then for gamma, neutral, so it just travels straight line, does not affected by electric field, not affected by electric field. Okay, alpha is positively charged and attracted to positive plate. Okay, for beta, negatively charged and attracted to negative plate. Okay. Okay, for Y, for gamma, no deflection at all, or straight line. Okay, gamma is neutral. Okay, so dari sini kita tahulah kan, dia punya tu deflection tu. Okay, arrange alpha, beta, gamma in order of increasing penetrating power, then suggest material for X, Y, Z. Okay, nampak alpha can be stopped by this material, meaning paper lah. Okay, X is paper, piece of paper. Beta can pass through paper and stop by aluminium. Okay, and then Z, lead or concrete, thick concrete. Okay, so this one showing the penetrating power. Okay, gamma is the highest penetrating power, that's why can pass through paper, can pass through PCM or aluminium, then can be stopped by lead. Okay, sources of alpha particle are not suitable to be used as tracer in medical industry. Based on your understanding of alpha's ionizing and penetrating power, explain the reason. Okay. Why alpha is not suitable to become tracer? Tracer is the, in medical one, maybe the patient will drink it in form of liquid, and then it will pass through the patient body. Okay, the alpha particles emitted, okay, will try to detect any abnormalities in the patient body. But why alpha not suitable? Because alpha, as we know, alpha is nucleus of helium. Nucleus of helium. It has a high ionizing power. Okay. Means it will, which will ionize the tissues in your molecule of tissues in the patient body, which can cause a defect. Okay, dia akan menyebabkan kerosakan pada tisu, and maybe will encourage a new cell to develop, like cancer cell, something like that. Okay, and at the same time, it is low penetrating power. Maybe it cannot pass through if there is a thick skin or there is a bones and part, that one it cannot, it already stopped, cannot pass through. So it means the okay, the function as a tracer cannot happen when we use it as a tracer, because tracer need to go into the body of the patient to detect abnormalities. So alpha is not suitable. Okay, due to a very low penetrating power, easily stopped just by maybe a thick skin or bones and all that. Penetrating power is low. So itu sebab kenapa tak boleh. Normally we use a tracer, something like gamma. Okay, so you can read more about this one. Okay, half-life. What is the meaning of half-life? Okay, apa maksud half-life? Okay, macam separuh nyawa, separuh hayat. Kalau bahasa Melayu ialah separuh hayat. What is the meaning of half-life? So definition for half-life is time taken for the sample of radioactive nuclei to decay to half of its initial number. Okay, let's say if initial number is 100, what is the time taken for the nucleus to become half, meaning become 50? So the time taken here, we call it half-life. Okay, for example, this is initial activity, 16. After one half-life, it become 8, half. Means half of it decay and half of it still remains. Okay, separuh sudah hilang, tinggal separuh. Okay, so separuh yang hilang tu kita panggil decay. Okay. Untuk half-life, we can use symbol T half. Okay, ataupun boleh guna T half macam ni. Ataupun capital T half pun boleh. So after one half-life, it become 8. Another one half-life, it become 4. Another one half-life, it become 2. Another one half-life, it become 1. Means initial, which is 16, after 4 half-life, it will become 1. Okay, so example, original amount 16. Let's say time needed to become 8, half of 16 is 1 hour. 1 hour is the half-life. Okay, after another hour, decay to become 4, half of 8. Half-life is constant. For this one, let's say if we mention half-life equals to 1 hour, means the value of 1 hour still remains until many half-life occur. Okay, so the time taken for radioactive nuclei to decay to half of its initial number. Okay, so half-life ni ikut material adalah constant. Example, radioactive material has half-life of 20 days. T half ialah 20 days. Calculate the number of days taken for activity to reduce to 12.5% of its initial activity. Maksudnya ialah initial one we can assume as 100% because mentioned in percent. So initially is 100%. After one half-life, it will become 50%. After one half-life, another one half-life, it become 25%. Separuh dari yang sebelumnya. After another one half-life, separuh daripada 25, 12.5. Means, from 100% to become 12.5%, it takes 3 half-life. 3 half-life. And the time given half-life 20 days. 20 days. Half-life ialah 20 hari. So for 100% to become 12.5%, the total time is 3 half-life. So one half-life is 20 days. So 3 times 20 means 60 days. Okay. So we calculate also by using this like decay series also can. Macam kita buat decay series tu. Okay. Ini decay kepada decay to half, one half-life. And this one decay to half, another one half-life. And 25% decay to half, another one half-life. So the total time taken, 3 half-life. Okay, so we get 60 days. Okay. Another method is by using this formula. Okay, this is the activity or the remaining activity after certain ataupun end half-life. Ini initial. yang awal. Okay. Total initial number also can be mentioned in form of activity. Activity per minute, activity per second juga boleh guna. Okay. Dari mana datang ni? Okay. Formula ni actually we can derive it. We can derive the formula. Okay. Formula dia macam ni. Let's say we have number of half-life ialah n fraction left. Selepas dia decay, berapa fraction yang tinggal? Contohnya, kalau awal ni ialah 100%, after one half-life become 50%. So, apa fraction dia? Okay, kalau 100% dia punya tu ialah 1 lah. Kalau 50%, fraction dia ialah 1/2, half. Jadi half. After 2 half-life, dari sini sampai sini 25%. 25% from the original is 25/100 ataupun 1/4. Or we can say half from here. Half daripada ni. Half times half ialah 1/4. Okay. And then next half-life ialah half from this one. Half times 1/4. So akan jadi 1/8. So let's try to write it again. Let's say one half-life, the fraction is 1/2. Half sudah decay, tinggal half. Okay. 2 half-life sudah jadi 1/4. 3 half-life akan jadi 1/8. So you boleh nampak dia punya pattern. If we continue, it become 4, 1/16. Okay, dia akan jadi 1/16. Macam tu. Okay, let's look at the formula. Kita boleh buat formula. Macam you buat dalam tajuk maths tu kan. Logical reasoning tu. Okay, ini half ialah half to the power 1. Ini ialah half to the power 2. This one is half to the power 3. This one is half to the power 4. So n1 half power 1. n2 half power 2. n3 half power 3. n4 half power 4. Okay, ini fraction left. How to calculate fraction left? Let's say initial one is NO. Awalnya ialah NO. After certain time taken, the remaining is N. So fraction left equals to N/NO. Ini fraction left. Okay. Let's say after N half-life. Kalau 4 ialah half 4, maksudnya after N half-life, dia akan jadi half power N. Okay. Let's say after N half-life. So the fraction left is N/NO equals to half power N. So you dapat N/NO equals half power N. So dari sini kita dapat N equals, okay, saya tulis warna lain. Okay, N equals half power N times NO. Nampak tak? The same formula I get. Ini formula ni. If you understand this formula, you can use this formula. If cannot, you can just use this method. No problem. Sometimes ini lebih senang, betul tak? You boleh nampak senang, you guna cara ni. You nampak tak di sini cara dia tunjukkan? Ni. Okay. 100, one half-life. Ini another one half-life. Ini another one half-life. So 3 half-life. Okay. So 3 half-life times 20, 60 days. Okay. So I just show how we get. Maksudnya formula ni is not just coming like that. Mean we can derive from somewhere. Kita boleh derive dia formula ni. Okay. Ini ialah number of half-life after n half-life. Sorry, number of nucleus. Number of nucleus after n half-life. Ini dia punya fraction left, half to the power n. And ini initial activity ataupun initial number of nucleus. Okay, cara dia. Ada loss kejap ke? Okay, line tak apa. Okay. Ada soalan boleh tanya Okay, so itu adalah teknik untuk jawab soalan. Untuk selesaikan soalan berkaitan half-life. Okay, now we look at decay curve for half-life also, but using the graph. Okay, so this one is the graph of activity against time. Okay, against time. The time unit, it can be days, it can be hour. Okay, activity per second, let's say. Okay, initial activity 300. Kalau ikut sini ialah initial dia, awal dia, NO. NO ialah 300. So kita ada dua decay curve sini, A and B. How to find half-life from a curve? Okay, kita cari dulu NO kat mana. Ini awalnya di sini. Definition untuk half-life tadi apa? Time taken for activity to become half. Kalau initial ialah 300, we need to find half of it, 150. Then use ruler, draw dash line like this. Okay, for A, you can rate dia punya value of time here. So ini ialah half-life untuk A. Okay, if you want to determine for B, okay, also same, draw dash line to B, baca ke bawah. Okay, so ini adalah half-life untuk B. So senanglah baca daripada decay curve. Okay. Find the time for the substance to reach the value. The value of what? Okay, the value of this one. Maksudnya kena carikan. What is half-life of A? Time to reach is 12 minutes. So just write down 12 minutes untuk A. And then B, the time for B to reach half is 8 minutes. So half-life is 8 minutes. Compare decay rate. Okay. You tengok yang mana half-life lebih pendek. Okay. Half-life of B is shorter. Okay. Half-life of B is shorter. Kalau half-life dia pendek, maksudnya dia lebih cepat decay. Okay, dia lebih cepat decay. So the rate, decay rate for B is faster than A. Okay, rate of decay for B is higher. Okay, because half-life of B is shorter. Okay, sebab half-life dia pendek, dia lebih cepat decay. Okay, decay rate is higher. Okay, dia punya number of nucleus lebih cepat lah, reduce. Okay, exercise, dia tengok exercise. No. A sample of radioactive material has initial activity. So ini awal dia, NO. Half-life, T half, 20 minutes. How much its activity after an hour? Okay, tengok. Half-life dia bagi minit, dia bagi time dalam hour. So you kena tukar lah. Time ialah 1 hour equals to 60 minutes. Okay. Number of half-life equals to time taken divided by half-life. Maksudnya ialah 60 divided by 20. So kita ada 3 half-life. Okay. Jadi 3 half-life. Okay. So if initial activity is 200, awal dia ialah 200. After 1 half-life, dia akan jadi separuh half-life. Ini 1 half-life. Okay. Half-life yang kedua, dia akan jadi 50. Another half-life, 3, dia akan jadi 25. So activity after an hour is 25 per second. Okay, itu macam tu kita selesaikan. Okay, Okay, soalan number 2. The current activity of radioactive sample is 200 per second. Half-life 5 days. What is activity of the sample 20 days ago, sebelumnya? Okay, maksudnya kita kena patah balik. Dia bagi N di sini ialah 200. Okay, 20 days, how many half-life? Kena kira dulu berapa kali. Okay, 20 divide by 5. Maksudnya 4 half-life. Okay, 4 half-life. Patah balik 4 kali. Okay. Ini berapa? 1, 2, 3, 4. Kalau you patah balik, you kena multiply 2 semua. Okay, 200. Sebelumnya ialah 400. 400 sebelumnya ialah 800. 800 before that is 1600. Before that is 3200. Okay, so activity of the sample 20 days ago is 3200. Okay, 3200 second to the power negative 1. Maksudnya kena faham soalan 20 days ago, patah balik yang sebelumnya. Okay, current tu yang ni, semasa. Okay. Number 3, radioactive material half-life 20 days. Calculate number of days taken for activity of the sample to reduce 25%. To reduce to 25% of its initial activity. Okay, dia dah bagi the half-life. Kalau 25%, maksudnya awal dia ialah 100, become 500, become 50, sorry. 50. Okay, and then become 25. Means 2 half-life. So number of days time taken ialah 2 half-life. So 2 times 20, 40 days. Okay. Okay, number 4, sample Y become 12.5% from its original after a day, 1 hari. Okay, so calculate its half-life. 1 hari ada berapa jam? 24 hours lah. Okay, kita kira by berapa hari ya. Okay, 12.5 maksudnya awal ialah 100, become 50, become 25, become 12.5. Okay, so berapa half-life? 3 half-life . Okay, 3 half-life. So means the time taken okay, 3 half-life equals to 1 day. 1 day ialah 24 hours. So half-life ialah 24 divided by 3 ialah 8 hours. So half-life dia ialah 8 hours. Okay, ataupun 1/3 1/3 of the day, 1/3 of the day ialah 8 hours lah. Okay, element X half-life 3 years, original mass 300. Calculate how much has decayed. Okay, after 12 years. Okay, awalnya ialah 300. Kalau 12 years, how many half-life? N equals to 12 divided by 3, maksudnya 4 half-life. So kita kena buat 4 kali 4 half-life. 1, 2, 3, 4. 4 half-life. 300 become 150, become 75, become 37.5, become 137.5 divided by 5. Okay. You divide by 2 lah. Okay. 8.75. 18.75. Okay. So means the fraction decay yang sudah decay, ini yang tinggal. Okay, left. Ini yang left. Yang kita catat ni yang masih tinggal. So yang already decayed, the decayed one ialah 300 minus 18.75. Okay, so kita dapat berapa? Itu adalah dia punya fraction ataupun how much has decayed. Okay, how much has decayed maksudnya ialah 200 81.25. Okay, is it correct? Okay, itu yang sudah decay. Yang left ini yang left. Okay, yang kita catat ni semua yang left. Okay, yang tinggal. Yang decay kena minus. Okay, itu 6.1 ialah radioactive decay. So untuk radioactive decay 6.1 tu you kena faham the decay process definition, and then the half-life calculation problem either from the information given atau decay curve. Itu kena faham. Application of half-life can come out in paper 2. Okay, the properties of the tracer, like one of the question just now. Okay, 6.2 nuclear energy. Atomic energy released during nuclear reactions such as radioactive decay, nuclear fission, and nuclear fusion. Okay, the first one, nuclear fission. Nuclear fission when heavy nucleus split. Split maksudnya dia terbelah dua atau terpisah dua. Heavy nucleus split into 2 or more lighter nuclei while releasing large amount of energy. Okay. Example, uranium-235 bombarded by single neutron. Okay, uranium-235 dia kena tembak dengan neutron. Okay, so dia akan jadi unstable. So when unstable, dia akan become more stable by process of nuclear fission. Uranium akan split kepada 2 lighter nuclei, barium and krypton. Okay, so at the same time release 3 neutron and large amount of energy. So ini ialah fission. Fission maksudnya dia pecah kepada 2 nukleus yang lebih ringan. Okay, sampai sini tengok uranium-235 bombarded by 1 neutron, so become unstable. So dia akan split kepada 2 lighter nuclei, at the same time release 3 neutron and energy. If you can see, uranium-235 require this neutron for the fission process. So the neutron that produced by one fission process, this one can bombard another uranium. Okay, so means it continue to produce 3 new fission process. And again, uranium akan release out another 3 neutron sini. Sini pun ada lagi 3 neutron. Ini pun 3 neutron lagi. You imagine kalau 3 neutron lagi hit another 3 uranium. Okay, berapa banyak energi ya, setiap satu kali fission sudah banyak energi ya, bayangkan banyak energi. So this one kalau tak stop, dia akan jadi chain reaction. Macam hydrogen bomb. Okay, it will explode and produce large amount of energy. Okay, so this neutron will bombard other uranium nuclei and release more neutrons through continuous nuclear fission. Jadi dia adalah proses yang tak boleh dikawal kalau kita tak halang neutron ni daripada collide dengan the next uranium, proses tu akan berterusan. Okay. Nuclear fusion. Fusion adalah proses terbalik. Nuclear fusion, small and light nuclei fuse atau combine, dia bergabung to form heavier nucleus while releasing large amount of energy. Happens under extremely high temperature and pressure. Okay, contoh di sini ialah kita ada deuterium and tritium. Ini lighter nuclei, lighter, ada dua yang ringan. Dia combine produce 4,2He, helium, which is heavier. Ini heavier. Release one neutron and energy. So ini satu sampel untuk nuclear fusion. Two lighter nuclei combine to produce one heavier nucleus. Release neutron and energy. Okay, ini satu contoh fusion. It require very high temperature. Normally this happen at the surface of sun, di permukaan matahari. Okay, di permukaan matahari. Okay. Okay, how to calculate nuclear energy? According to Einstein, before and after process of fission or fusion, when you calculate the mass of nucleus before and after, you can see there is a difference in mass. Mass before and mass after. Normally, total mass before is higher than total mass after. Contoh macam ni ya. Ini ya, nampak total mass before 15.5 atomic mass unit. After it become 14 atomic mass unit only. Means there is mass defect atau mass loss. Mana pergi mass yang loss tu? 1.5 AMU. According to Einstein, the mass defect or mass loss change to nuclear energy. So nuclear energy come here atau produce di sini due to mass defect. Okay, so Einstein produced this equation, E equals mc squared. So nuclear energy equals to mass defect multiply speed of light square. Okay, speed of light square. Okay, so mass defect kita akan belajar dalam unit ni ya. Atomic mass unit. Kenapa dia guna term atomic mass unit? Sebab one unit, one atomic mass unit is very very small, 1.66 times 10 to the power of negative 27 kilogram. Mass of nucleus also very small. Mass of proton also very small. So if you state, you need to state in this form, 10 to the power of negative 27, 10 to the power of negative 31. So the more practical way is to calculate it using atomic mass unit. Okay, atomic mass unit. Okay, AMU. Okay, after you have calculated the mass defect in AMU, then you can convert to kilogram again. Okay, 1 AMU just now is 1.66 times 10 power negative 27. So you just multiply with unit AMU, you will get in unit kilogram. Why we need to convert to kilogram? Because when you apply formula E equals mc squared, you can see the unit of C is meters per second, unit of E is joule. Ini meter per second. Means the unit of mass also must be in SI unit, kilogram. Okay, kilogram. Example, alpha decay radium 226 nucleus represented in the equation. Some other relevant information is included. Based on the equation, calculate mass defect, energy produced from the reaction, power generated if reaction occurs in 10 microseconds. Okay, mass defect, kalau you tengok radium 226 dalam equation tadi, ya, Radium-226 become radon-222, release out 1 alpha, at the same time is nuclear energy. Mass of radium normally all given in AMU. Okay, ingat what 1 AMU is 1.66 times 10 power negative 27 kilogram. Okay, mass defect, you just take mass before minus mass after. Mass before is mass of radium 226.02540. Don't rounding off, just copy down. Sometime until 4 or 6 decimal, salin je apa yang diberikan. Minus mass after radon and helium. Okay, you get 0.00523. Ini dalam unit AMU. Ini AMU. Bila you nak guna formula E equals mc squared, you kena convert to kilogram dulu, mass defect. Okay, multiply 1.66 times 10 power negative 27. So you get 8.6818 times 10 to the power negative 30 kilogram. Okay, nampak tukar kilogram. Sudah tukar, baru ganti dalam formula ni. Mass defect multiply speed of light, 3 times 10 power 8. Ini adalah speed of light, ada beri dalam this, square. So you get 7.81 times 10 to the power negative 13 joule. Okay, if you want to convert to EV also can. 1 EV equals to 1.6 10 to the power negative 19 joule. If you want to convert to EV, you just divide joule with 1.6 10 power negative 19. Okay, so you will get in EV. Okay, so ini akan dapat jawapan dalam EV, electron volt. Okay, next is power generated. Power is E divided by T, energy divided by time. So the time is 10 micro. Micro ialah micro, 10 power negative 6. So power sudah calculate, energy sudah calculate tadi dalam joule, divide by time, you get 7.81 times 10 power negative 8 watt. Okay, ini dia punya power. Okay, exercise. Okay, speed of light in vacuum, 1 AMU, 1 EV. Calculate mass defect in the reaction in kilogram and in AMU. Okay, let's say kita ada ni E equals mc squared. Okay, so you get M equals okay, this one is in kilogram. You want to change to AMU, 6 times 10 power negative 27 multiply 1.66 10 power 27. Okay, now you need AMU. Sorry, saya divide. Bukan multiply, divide. Should be divide lah. Sebab kalau you tukar kilogram kepada AMU kepada kilogram, baru you multiply. Sekarang dari kilogram tukar AMU terbalik. Okay, given mass defect, calculate energy release. Okay, so you're going to convert AMU to kilogram, then multiply dengan speed of light squared. This one, the power equals E divided by T. Okay, calculate mass defect, MC squared divided by T. Okay. Okay, number 4, you can try yourself. You just calculate mass defect before and after. Ini ialah before, ini after. So you calculate M in MU and then you convert to kilogram. Use the formula E equals MC squared. Okay, before we end, this one is the last part, generation of electrical energy in nuclear reactor. So the process of fission normally used in order to produce electricity in nuclear power station, nuclear reactor. Use is uranium-235, produce heat energy by undergoing nuclear fission. Water pumped into reactor core, absorb heat energy. Temperature water increase until reaches boiling point. Water changes to high pressure steam that will flow through the turbine. The high pressure steam rotates the turbine. The turning of the turbine rotates magnet or coil in generator. The steam cools down and condenses into water. Electromagnetic induction occurs in generator to produce electrical energy. Electrical energy generated is sent consumers VIA, power supply transmission system. Okay, ini adalah konsep untuk generation of electrical energy guna nuclear reactor. Okay. Structure of nuclear reactor, you boleh refer buku teks. Okay, the safety features, kita ada thick concrete wall, prevent radioactive radiation from leaking. Dinding dia tebal, concrete dia tebal. Water as cooling agent, guna water to absorb heat and control reactor temperature. To control rates, because nuclear fission, nuclear fission, if we don't control, this one will produce chain reaction. This one kalau tak control dalam nuclear reactor, finally nuclear reactor will explode. Macam yang berlaku di Chernobyl, Russia. Okay, nuclear fission dia proses digunakan untuk produce high energy, heat energy, to change water to steam. Okay, the steam will rotate the turbine. Turbine will cause the coil to rotate in the magnetic field, produce current by induction. Okay, inside, to control rate of nuclear reaction, you can use control rod. either boron or cadmium to absorb excess neutron. Maksudnya dia control guna sebab satu fission akan produce 3 neutron. So just absorb 2. Only left 1 for the process. So control process by using boron or cadmium. Moderator slows down the fast moving neutron because the neutron that to use to bombard neutron is slow moving, not fast moving. So we need to slow down the neutron so that it will bombard the uranium to produce process of fission. Okay, normally moderator is made of graphite or water. Okay, so means for this topic of nuclear reactor, once come out in paper 2, pernah keluar juga paper 2, structured question, section E. Okay, ini pernah keluar. So I think that's all. Okay, that's all our class tonight. So for those who, if you left some of this part, you can watch later because this is recorded in YouTube. Okay, so I think that's all. Thank you for joining me. Bye.